Okay, guys, so we're jumping ahead a couple sections just because I kind of like this topic, and it's pretty easy to do. And there's some things that we're going to do on Desmos as well to solve a couple of these problems. So it's called area between curves, and what we're essentially going to be doing is you're going to try and figure out when you have two curves given, okay, you're going to try and figure out the area that's in between them, okay? So up to this point, right, I would give you guys like an equation, right? And then if you were to graph it, put this in a different color, you would look something like that, right? Okay, and then if I said, like, I want you to go from, say this point to this point, right? You would do the definite integral then from a to b, right? And that would give you the area as you work your way down from the curve all the way to the x-axis, right? So that would give you the area between a to b of f of x, right? And then say, for example, I gave you another curve, right, that looks maybe something like this. All right, and we're going to call that, say, g of x. All right, and if I said, all right, now figure out the area of g of x from a to b, right? And if you did that, this is the area that you would be finding, okay? So our goal now is to actually just figure out what's here, okay? So when you do this process, right, the big thing to remember is top minus the bottom, okay? So you look at the top curve, okay? That'll figure out the area as you go from the top curve, which in this case is the blue one. So you're finding the area of the blue curve all the way down to, you're going from the blue curve all the way down to the x-axis, right? You're finding all of that space, right? And then when you figure out the area for the second curve, right, which is here in the red, okay, you're going from, again, the red curve down to the x-axis. So it's this space here, okay? Now, when you do that second part, right, they have all this inner overlapping area, okay? So what that does is that this overlapping area ends up going away, okay, when you do the top curve minus the bottom curve. And what you're left with would be just in the middle, okay, what's not being overlapped, okay? So it's like you have the whole thing here, and then when you add in that second equation, it takes away what they have in common, and what is left over is your answer that you're looking for, okay? So the big key here to remember is we're going to do top minus the bottom, okay? So for the first example, let's just find the area bounded by negative x squared and x between the vertical lines of negative 0 and 1. Okay, so it's really helpful to kind of draw these out the best you can. Doesn't have to be perfect, but you should kind of have an idea of what these graphs look like. Okay, so the first one we know is negative x squared. All right, so that looks something like this. So this is negative x squared, okay? And then the second one is going to be just x, okay? Which looks something like that. Okay, so that's g of x equals x, right? So I know the area that I drew is not great. It's not very big, but what we're essentially going to be doing is we know that this is negative 1, because that's the point that I gave you, and we know that that's 0. Okay, so we're finding the area between this little space right there, all right? So when we do this, okay, you always want to go, when you write your integral, you're going to go from left to right. So it's going from -1 to 0, all right? And then you're going to do the top curve minus the bottom curve, okay? So it's going to be -x squared, because that's on top, that's the blue line on top, minus x, which is on the bottom, which is the red line, and then dx, okay? And then what you guys would do is just do your definite integral like you normally would, okay? So this is going to be -x cubed over 3 minus x squared over 2, and we're going to go from -1 to 0. Okay, so when you plug in 0, right, you get 0 over 3 minus 0 over 2 minus, this is going to be positive 1/3 minus 1/2. Okay, so this ends up coming out to be 0 minus, so this is 2/6 minus 3/6, okay, which is -1/6 times the -1 out front becomes positive 1 over 6. Okay, so that would be your answer for that one. Okay, and then looking at the second one, it says figure out the area between x squared plus x plus 2, and then -x, and the vertical lines 0 and 2. Okay, so again, I kind of want to draw this out. All right, now I don't know exactly what x squared plus x plus 2 looks like. I just know it's a quadratic, it's a positive quadratic, so it's going to open up, and I see that the intercept, the y-intercept is going to be 2. All right, so it's probably going to look something kind of like that. All right, and then the second line is -x, right? So -x is here. Okay, now these don't intersect, which is fine, okay, but it says that it has to go between x equals 0, which is like here, and then x equals 2, which we're going to say is like right there. Okay, so the area that we're going to try and find now is here. Okay, so again, we need to do go from 0 to 2, and we're going to do top minus the bottom. So the blue curve is on top. All right, so I'm going to do x squared plus x plus 2 minus the bottom, which is the red line, which is -x dx. So you guys want to try and simplify this as much as you can before you try and find your answer. So plus x plus 2 plus x again. So this is going to give me x squared plus 2x plus 2. So we're going to go from 0 to 2. Okay. So I got x cubed over 3 plus x squared plus 2x from 0 to 2. Okay, so if I plug in 2 now, I'm going to get 8/3 plus 4 minus 0. So this would be 8/3 plus 8, which is really 8/3 plus 24/3, which is then 32 over 3. All right, so again, we're just doing top minus the bottom. Okay, now for number 3, we don't have intersection points. It just gives us the two equations, and then that's it. Okay, now it's just going to add a little bit of extra work for us, but it's not really that hard. So what you want to do is, you want to figure out where do those two equations equal each other. Okay, that's where it says find the points of intersection. We want to figure out where they cross each other. Okay, so all you have to do is just set them equal. Okay, so you just take the two equations that you're given and you set them equal. Okay, and then you solve it like you've been doing since Algebra 1. Okay, so this will, if I put everything on one side, this would be x squared minus x minus 6. And then if I factor, plus 2, this will tell me that they're equal at 3 and negative 2. So now when I do my integral process, I know that I have to go from negative 2 to positive 3. Okay, so when I draw my graph now, okay, so I know that 6 minus x squared, that's a quadratic, that's opening down, okay, and I know that the intercept is 6, right? So it's going to probably look something like that. Okay, and then negative x, all right, looks something similar to like that. Okay. All right, so what we're trying to find now is the area between these two. Okay, so I know that this is negative 2 because that's the algebra that I did to figure that out. So that's this point here. And then this point down here is going to be positive 3. Okay, so when we do the area now, going from negative 2 to 3, and then you're doing top minus the bottom. So the blue curve is on top, so you're doing 6 minus x squared minus the bottom, which is negative x, which is the red line on the bottom, okay? So this is going to give me negative x squared plus x plus 6, and we're going to go from negative 2 to 3. Okay, so antiderivative, I'm going to rewrite that. And then we're going to go from negative 2 to 3. Okay, so when I plug in 3 now, right, I'm going to get negative 27 over 3, which is negative 9, plus 9 over 2, plus 18, minus, plug in negative 2 now, I'm going to get, that's going to be positive 8/3. Plus 2 minus 12. Okay, so if I simplify now, right, I got 9 plus 9 over 2 minus 8/3, and then 2 and negative 12 is negative 10, times the negative out front is plus 10. Okay, so this gives me 19 plus 9 over 2 minus 8/3. Now, common denominator would be 6. So if I put this over 6, 19 times 6 is 114. That's 27. And then that's 16. All right, so if you 114 plus 27 minus 16 is going to give you 125 over 6. So that would be your area. Okay, so I'm going to skip a couple, and then I'm going to go down to number 6 here. So it says use Desmos to figure out the region between 3x cubed minus x squared minus 10x, and then 2x minus x squared. Okay, so you guys can use your graphing calculator or Desmos. I think it's pretty easy on Desmos. Okay. Okay, so what I'm going to do is I'm going to open up Desmos now. Okay, now what I'm going to do is I'm just going to give these a name. All right, so the first equation, okay, I'm going to call 3x cubed minus x squared minus 10x, okay? So that's going to be the line in the black there. And then the second one, I'm going to call g of x, okay? And that's going to be 2x minus x squared, all right? Okay, now if I get rid of this, right, we should be able to see the areas, right? So it looks like I have one from -2 to 0, okay? And then if you guys see, the black line is on top, and then the red line is on the bottom. And then once I get to 0, and then I go to 2, okay, that ends up changing, okay? So for this example, we're going to need to do 2 equations instead of 1, okay? Okay, so what I'll show you, right? So I'm going to go back to my notes, right? So we know that the graph go back to look at that real quick. Okay, so looks something like that. All right, that was going to be f of x, and then g of x is something that looks like that. All right, not perfect, but it's okay. So again, what we need to do is that area and then that area. Okay, so we're just going to be adding them together. Okay, so if you look back on Desmos, right, to figure out where they're equal, okay, just touch on where they intersect, okay? So for the first one, I'm going to go from -2 to 0. All right, so this is -2, that's 0. All right, so the area is going to be -2 to 0, right? And we called this one f of x, and we called the red one g of x. So we'll do f of x minus g of x. So if you guys give it a name, you can just write it like that, okay? And then the second one, we're going to go from 0 to 2. Okay, so that was the other intersection point. That was 2. Okay, now we're going to do g of x minus f of x, okay? Because now the lines switch, right? The red line's on top and the blue line's on the bottom, okay? So I'm going to go back to Desmos now, and the nice thing about Desmos is that it can do all the work for me, okay? So if you want to do an integral, okay, what you're going to do is you need to type in int, all right, and that'll give you the integral formula. All right, so we're going to go from -2 to 0, okay, and then in parentheses, okay. You guys don't need to retype in the equation if you've already given it a name, all right? So because I've already called my equations f and g, I'm just going to retype them in. So the first one is going to be f of x minus g of x. So f of x minus g of x. Okay, I'm going to close the parentheses, and then don't forget to type in dx. Okay, so it says that the area then from -2 to 0 is going to be 12. Okay, now I have to just do the second part. So I'm going to add in a plus sign and then type in int again. Now I'm going from 0 to 2, so I'm doing that second region, and now I just have to do g of x minus f of x. Close parentheses and then dx. Okay, so your final answer for this one is just 24. Okay, so just be careful when you're typing it in. Sometimes it won't recognize it if you don't have the right number of parentheses or anything like that. Okay, so I'm going to go back to here, and we're going to say that the final answer there is 24. Okay, so if you guys are using Desmos, as long as you make sure to have your setup. So show your setup. Okay, and then you don't need to do the long way out. If you're using the calculator, you can go right to just giving the answer. Okay. So we'll do one more. All right. It says use Desmos. 2x cubed minus x squared minus 14x, and then 4x minus x squared. Okay. So I'm going to go back to Desmos. I'm going to get rid of that. Now I'm not going to get rid of f and g. I'm just going to retype them with the new equations. All right. So 2x cubed minus x squared minus 14x. Okay, and then g of x I'm going to call 4x minus x squared. Okay. All right, so it looks pretty similar, right? Then from the last one. Okay, so looks like we're intersecting there at -3, 0, and then +3. Okay. All right, so we've got f of x and then you got g of x. All right, so that's g of x. And then the blue one we're going to say is f of x. So we're doing this area first, and then this area second. All right, so we figured out that this was -3. This is 0, and then this point here is +3, okay? So we have to do two integral equations again. Now, you guys don't always have to do two equations every time. It just happens to be, for this example, we have two areas that we have to find. So, so the first one, again, is going to be f of x minus g of x, okay, top minus the bottom. And then you're going to add with that the integral from 0 to 3 of g of x minus f of x. Okay, so I'm going to go back to Desmos and I'm going to type that in. All right, so again, it's int, and then you're going to go from -3 to 0. Okay, and then the first one again is top minus the bottom. All right, so again, you look at that, it's the black curve on top and the red curve on the bottom. So f of x minus g of x. And then you're going to add with that the integral from 0 to 3. And then that's going to be g of x minus f of x. All right, that's the second area. The red line's on top, the black line is on the bottom. Okay, so it looks like our answer here is going to be 81. All right, so your final answer is 81. Okay, so when you guys are doing these, again, if it doesn't say use Desmos, you kind of have to do out the long way. Okay, if you're not really 100% sure on what the functions look like, plug it into Desmos and then kind of go from there. But you should be able to do it out the long way, and then also the short way as well. Okay, so if you have any questions, please let me know. Thanks.